Hey everyone, it's Mr. Boyden here, back at it again today. And today we're going to be talking about rotations. This is going to be the fourth kind of transformation that we've learned about so far. And so before we dive into it, I do want to do a really quick review with you, just to make sure we understand the basics of what each of these four kinds of transformations are. There's four that we've learned about so far. We've got the translation, rotation, reflection, and dilation. And so what I want to do is I'm going to grab this shape, and I want you to try to figure out which of these four transformations I'm doing when I make a movement with the shape, or when I transform the shape in some way. So first one I'm going to do is I'm going to go like this, and what I want to know is that a translation, rotation, reflection, or dilation. Okay, that one is a translation. Translation is like when we shift. We shifted it left and right, it didn't flip, it didn't turn, it didn't change size, nothing like that. That was a translation. Now I'm going to do a different one. What was that? What did I just do? Did I reflect it? Did I dilate it, rotate it, translate it? I just changed the size. If the size is changing, that automatically means it was a dilation. Okay, let's do another one. What did I just do? That one was a rotation. I turned it. And so we're going to learn how to do that today, and that's what the focus of this video is going to be on. And the final one is reflection, and in this software, I don't have a meaningful way of reflecting this. But if you remember that's like flipping over a line, then that'll be useful to keep you understanding what it is. So with that said, let's learn a little bit about rotations. Okay, so rotations require two things. Well, we need the points, but then we need an angle, and we need what's called the center. So let's make up some points, and we're just going to do a couple of examples together. So for the first one, I think I'll do the points 2, 1, and let's graph that. 2 to the right, up 1. And let's do 3, 5. So over to the right 3, up 5. And let's do 0, 3. And let's rotate that 90 degrees clockwise, about the origin. Okay, and that just means the origin is the place that these points are going to be connected to. So that's the place that's not going to be moving at all. It's the same exact idea with a dilation. We had that point that everything is stretching away from. This means the origin is the point that everything is going to be rotating around. So I'd like to remind you, clockwise means we're moving in this direction. Some people like to say it's to the right. That's kind of misleading on a clock. I mean, you could say that's right, but you could also say that's to the right. And so we usually want to actually show the motion that that's what clockwise is. And we probably want to try to avoid this type of explanation. Okay, so with that, now we're going to try rotating these points. And without me giving you a manipulative, it's really, really hard to show that. So what I'm going to do is I'm actually going to pull up some graphing software. Alright, so I've got my graphing software here, and I'm going to show now in the graphing software how we can understand this a little bit more easily. And so in order to do this, I have to highlight my points. I have to tell them where the center is, the point that's nailed down, and then the software will actually do the next part for me. Now in class we use patty paper to do this, and on a test you'll be allowed to use patty paper if you're in my class, but I don't have that in front of me, so this is what I'm going to use. And so to show you what a rotation looks like, I'm going to start playing with smaller numbers. So I'm going to start out with 10 degrees. And so I hope you can see that this shift has started to move, or this shape has started to rotate to the right, and it's spinning around the center here. Think of it like the Earth is spinning around the sun. This triangle is the Earth. It's going around the sun, and so it's just going to work its way around. So what would 20 degrees look like? It's a little bit further. 30 degrees, 40 degrees, 50, 60, 70, 80, 90. Now I know that's not a super, super smooth transition, but I think that will work. So I'm going to grab a screenshot of this really quick, and we're going to take this back to our other page so we can try to understand it just a little bit better. Okay, so here we are back with our original question. We want to rotate the point. So visually, if we were asked just to graph it, we've done that. That's right here. So the points have moved. I want to talk with you a little bit, though, about what happened to the coordinates. So let's talk about which point went to where. And in order for this to make sense, we probably need to give these names. So I'm going to call this points A, B, C. And so remember, it rotated this way. So where did B land? Where is B prime at? Rotated around. B prime is out here. And so let's start with that. Let's get the coordinates. Now remember, this came from the coordinates 3, 5. That's right here. Point B. What are the coordinates of this point now? So it looks like we're 5 to the right and we're down 3. So that turned into 5, -3. All right. And A is right here. A is at 0, 3. And where did A go to? A rotated down to here. So here's A prime. Now let's find the coordinates of that point. Looks like from the origin we have to go right 1 and down 2. So that would be 1, negative 2. Now let's determine where point A rotated to. The shape rotated down, so A prime lands right here. Let's figure out the coordinates. That's 3 to the right. Okay, so 3, 0. And that's A prime. And then what about C? C had the coordinates 2, comma 1. So there's C. Where's C prime? C prime came down to here. And so now we have the coordinates 1, negative 2. Okay, and so here's the question that I'd like to try to answer, because it'd be nice if we had some deeper understanding of this. How do the points given originally turn into our new points, our prime points? What's a pattern that you look at if you compare the coordinates of C to C prime? If you compare the coordinates of B to B prime and compare the coordinates of A to A prime? What's a pattern that you see? Pause the video and try to write down 1 to 2 sentences about what you see happening. Okay, here's what I see happening. I see in all 3 of these cases, the x and y values switch. And here's what I mean. 2 is an x value. There's a 2 in the y value. There's a 1 in the y value. It switched over to become an x value. Same thing here. This was 3, 5. It became a 5 and a 3. Switched order. 0, 3 became 3, 0. There's one other thing I also notice. One of the values went negative. One of the values went negative. It's hard to say if one of these values went negative, because when you go to 0, negative 0 is still 0. So it seems like maybe it did. So I'm going to write that down, and we're going to generalize this. In a 90-degree rotation, what happens is we switch x and y. Okay, so x and y get switched. And what else? One of the coordinates goes negative. Now, I'm not about to say that it's always the y value, but I'm going to say, and one sign gets switched. Okay, and what I mean by that when I say the sign gets switched, the only reason it went negative is because we started out with all positive numbers. Now, if we had started out with negative numbers, then one of these would have become a positive. So when I say the sign gets switched, I mean either it goes from negative to positive or positive to negative. Now, let's try another example, but this time we'll rotate the other direction. In this example, we're asked to take a shape, and we're going to rotate it 90 degrees again, but this time we're going to do it counterclockwise. So in order to understand this, let's try to first make a prediction about what we think is going to happen. So we know it's going counterclockwise. So let's try to figure out where we think these points are going to land. We're going to make our best guess, and then we'll also go check it with the software. So if we started out at negative 3, 4, what do you think the point that goes with that, the image point of that, is going to be after a rotation? Remember, it's 90 degrees, and if you need to look back at your notes, look at the one we just did. What happened to these values? What we know for sure is that these numbers are going to switch. There's still going to be a 4 and a 3. They're going to be in reverse order. It may or may not be clear yet if they're positive or negative. But we can think about it this way. If we have this point and it's rotating somehow down over here, it's going to land somewhere down in this vicinity. Now down in here, is the x value negative or is the x value positive? We're to the left of the axis, so it's negative. What about the y value? We're rotating down, so where is it that we are? Are we above the axis, below the axis? Looks like we're below. So that means our y value is also going to be negative. Okay, so without even drawing it, I can figure out those coordinates. What's going to happen here? We're going to have a 2 and a 5. They just switched. It was 5, 2. Now it's 2, 5. We also need to try to determine whether or not they're positive or negative. So we're from this point now, or excuse me, we're from this point, 5, 2. So that's going to rotate over into this quadrant. Now notice, we move one quadrant to the left, or one quadrant counterclockwise. So over in quadrant 2, we're to the left of the x-axis, so we have a negative x value, but we're going to be above the y-axis, and so we're going to have a positive y value. What about this one? Okay, again, we're going to switch the coordinates. 7, 2. Okay, and that came from this point up here. It's going to rotate over to here into quadrant 2, And so what are we going to have? Looks like we're moving to the left, so we're going to have a negative x value still above the axis, so a positive y value. So people, this is my prediction about what the coordinates will be. I have a pretty strong indication based on what I see here because I've rotated the points. I don't even know where they're going to land yet visually, but algebraically I can figure this out, or analytically I can figure this out because we already said 90-degree rotations switch the x and y values, and we're going to change one sign. And look, I've done that. I used the visual of rotating with these arrows to show about where these points will land. That told me what would be negative. Now let's go over to the geometry software and let's see if this is actually correct or not. Alright, so here we have our geometry software, and let's try to now make a rotation. So I'm going to select my information here, and I'm going to make sure I don't include the axis and I don't include that straight point because I'm not interested in those. I'm going to let the software know this is my center of rotation, and now I'm going to actually perform the rotation. So let's transform, let's rotate, and I want to make sure I'm going in the correct direction. This is actually, I know it seems counterintuitive, this is actually the positive direction though. And so here is my shape. So I'm now going to take this. Now we can look at this and use this model from Geometry Sketchpad, from our geometry software, to see how our prediction worked. Now, when you have a test, again, you're going to be using patty paper. You're not going to have necessarily a computer to work with. So we're going to use the technique that we learned in class, but if you don't have my class, then you can use this software, or at least this provides you a visual for a way to understand it. Let's check and see if these points are accurate. So I had said we would have -4, -3. Let's see. Left 4, down 3. Hey, there it is. That was right. -2, up 5. So left 2, up 5. Hey, there's a point. And -7, 2. So -7 and 2. Okay, so I hit all those on the head. Now going back to how I did that, remember I said we're going to move to the left. So, or we're going to move counterclockwise. So this point rotated from where it is. And think about this as a big circle going around. And this origin being in the very center of the circle. You're going to move 90 degrees on that circle. So you're going to move 90 degrees down to here. This is going to move 90 degrees over to here, and this is going to move 90 degrees over to here. And guys, I've been using the language quadrants. Now, if you're not familiar with that, quadrants are just the 4 areas that when you have a graph with an x and a y axis, it breaks it into 4 areas. And so if we're moving counterclockwise, we're going to move to the one that's counterclockwise. If we had a clockwise rotation, it would go from here, and each point would land in a different quadrant, in a different area of the graph. Okay, and from there you can tell, well, here the x and the y value is positive. If you're down here, the x value is positive because we're to the right, but we moved down from the axis, so the y value is negative. Okay, and so on. Okay, let's do one more. All right, this is going to be our third and final example today. I've picked 3 points, and now notice the difference. We're going to be doing a 180-degree rotation. So, and then I had kind of a smart way of thinking about this over here, a smart aleck way of thinking about it. Does it really matter? Let's talk about why I wrote that. Okay, imagine yourself and you're facing wherever you are. If you spin counterclockwise or to your left 180 degrees, what direction will you be facing? The exact opposite direction of where you started. So that's if you turn counterclockwise 180 degrees. What if you turn clockwise? You're still going to be facing backward. So that's why I said it doesn't, or does it matter? Because no, it doesn't really matter. If you turn 180 degrees counterclockwise or 180 degrees clockwise, the final result, the direction that you're facing, is exactly the same. It's a 180-degree turn or half of a full turn. So imagine for a second what's going to happen to this shape when we do a 180-degree rotation. One way of thinking about it is it's like it's going to be upside down. So right now it looks nice and peaceful sitting here. It's going to be upside down in just a minute, and it's going to go down one of these 2 directions. And it really doesn't matter which one we pick because, again, it's going to be the exact same thing. Let's see what our geometry software has to say about this. So we'll do a rotation, and this time I'll type in 180 degrees. And there it is. So we talked about the shape being upside down. So here it is. It's upside down. This was our right side up shape. This is our rotated shape, or our shape with all of our prime points on it. And there it is. So let's get a screenshot of it back in the other software, and let's see what we have. All right, so now that we're here, let's try to steal some coordinates off of this. So the first one that I notice is I'm down here, and looks like I'm 1 to the right and down 4. So that would be 1, -4. Okay, and you know what? We better give these labels so we can understand which one is which. So I'm going to call that A. and that would mean that is A prime. And here they are. They go together. These are the points that are associated with the letter A. And then let's pick this one as B. Where did this one land? Did it land on the right or the left over here? Now remember, 180-degree rotation. So B prime is over here. And what are the coordinates? Left 3, down 3. So that would be -3, -2. All right. And then what happened to that final point? I'm going to call that C, and that would mean this is C prime, and that would be 3 to the right and down 2. So 3 to the right, down 2. All right, so it's the same question as that first example. I'm going to box these off so we can see which ones go together. So in our first example, I had asked, what is the pattern in these numbers? How do you turn one point, or one set of points, into the other? So take a look, pause your video, and write down one sentence about how you get from this line to that line. Did you notice that it's all the same numbers? They're all in the same places. So 3, 3, 2, 2, 3, 3, 2, 2, 1, 1, 4, 4. The only difference is what? It's that they went negative. So 3 and 2 became -3, -2. -3, 2 went to be the opposite. So -3 turned into 3, 2 turned into -2. -1 turned into a +1. So when you have a 180-degree rotation, the same thing always happens. Each value, or each coordinate, changes sign. And that's always going to happen. And does it matter which direction we rotate? No, not even a little bit. Okay, so that's always going to happen. That's kind of a shortcut for us. Now, in general, we're often asked to do one of two things, like for an assessment, for example. You'll either be asked to produce a visual, and in which case you need to actually sketch out the visual, or oftentimes you'll also be asked to provide the coordinates. So 180 degrees, that's a really easy one. It doesn't require that much thinking. It's just if you see a 3, you write a -3. If you see a 2, you write a -2. If you see a -3, you write a 3. Those are no big deal. And then if you're using patty paper, you use patty paper to make your sketch. You actually sketch it on the paper and you will rotate it around 180 degrees. That's going to be all for this first video on rotations. Hope you enjoyed it, and hopefully it leads you to some success as you study. That's all for now. We'll see you next time.